Hello everyone. So today we are going to discuss about Newton's law of gravitation. So as you all are very aware that along with the three laws of motion, Newton published the law of gravitation in 1687, right? And according to him, every particle of matter in universe attract each other with force that is directly proportional to product of their masses, and it is inversely proportional to square of the distance between them. So what we can write? We can write force is directly proportional to product of their masses. Now what we are talking about m1 and m2, let's say we have this particle and let's say this is the another particle. Let's say its mass is m1 and its mass is m2, and the distance from their center is considered to be r. So what Newton published that the force that is existing between these two particles due to gravitation is directly proportional to product of their masses and inversely proportional to square of the distance between them. Now, collectively what we can make F directly proportional to m1 m2 by r square. Now, what we have to do? We have to remove this proportionality and brings the equal to sign. When we are removing the proportionality sign and bringing the equal to sign, we have to put some constant. Here the constant is g and remaining thing will be same. This g, this is called universal gravitational constant, right? It is obtained after removing the proportionality and bringing the equal to sign. And the important point is that let's say x is proportional to y and we are removing this proportional sign and bringing the equal to sign. Let's say after doing this, we bought this constant k and let's say this is y x. So x becomes ky, and when we talk about this k, it is equal to x upon y. The important point to note is that this k does not depend on this x and does not depend on this y. If we are going to increase this x, this k will not going to increase. If we are going to increase this y, this k will not going to decrease, right? So it is independent, and that is why it is called proportionality constant. Here we are having the universal gravitational constant and it is called proportionality constant. So according to Newton, we obtained this F is equal to G into m1 m2 by r square. All right. Now talking about this G, it is because this is constant, proportionality constant, its value remains fixed throughout this universe. Whether we go to the Mars, Jupiter, Saturn, removing this, moving away from our solar system, going to the another galaxy, this G will remain constant and its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. This is its value. So now important points to remember here is that unlike the electrostatic force, this gravitational force is independent to the medium between these two particles. So whether these two particles are kept inside the water, gravitational force remains the same. Whether these two particles are kept in the vacuum, the gravitational force remains the same. So this is the first point that is to be remembered. It is conservative in nature, means if we are going to do some work using this force, then what will happen? This force will depend on initial and final position of the body, not on the path followed by the body. So this is the conservative in nature, right? Now when we talk about this, so we come to understand here that the here when two particles are here, then there exists a force that is g into m1 m2 by r square. This is gravitational force. Now so let us talk some conceptual point over here, that is extra point that you should remember is that first, if we are dealing with the point masses, let's say we have this m1 and this is the another point m2 and they are separated by a distance r, then definitely this force, the force existing between these two particles will be g into m1 m2 by r square, right? If we are dealing with spherical body, this one m1 and m2. So distance between from their center is r. Again the force between them F is equal to g into m1 m2 by r square, right? Now when we are dealing with point mass and solid cylinder or rod or anything, then we cannot say that. Let's say, let me draw the diagram over here. Let's say I am having one rod, okay, and in front of this rod I put one point object. Let the mass of this point object be small m and the mass of the rod is capital M, and from their center I am going to take the distance, right? So this is the distance. Let's say this is distance r. So here we cannot say that F is equal to g into m, capital M upon r square. This is not correct, right? We have to use the calculus to find the gravitational force that is existing between this rod and the small particle, or unit particle small m. Likewise, we cannot say that. Let's say again I am having one rod, its mass is capital M1, and another rod is also here. Let's say its mass is capital M2. And from their center I am taking a distance. Let's say this distance is r. In this case also we cannot say F is equal to g into m1 m2 by r square, right? It is not correct. So this is not correct, this is also not correct. In that case, this it we have to use the calculus. So let's deal this problem. Let's say we have a mass m, all right, and it is at a distance a from the end of the uniform rod whose length is L. Okay, this is the uniform rod and its length is L. Uniform rod means the mass is uniformly distributed, okay, over this length L of the rod. And from here, at a distance of a, I kept a small particle. Let's say the mass of this small particle is m dash. Now we have to find out the gravitational force that is existing between these two particles. As I mentioned earlier that we have to deal with the calculus. Now we are going to deal with the calculus. Now what I am going to do, let's say this is my rod and I took this derivative. Let's say this length is dx. Now what we are going to do here is that I will be finding the gravitational force of this small dx with respect to this small mass m. Okay, this is the mass m dash and the distance between them is a. All right. Now, after finding the gravitational force that is existing between this small element dx and particle mass m dash, I am going to integrate over the length of the rod. So, once we get the gravitational force existing between this element and small mass m dash, then what we have to do? We have to integrate it over the length. All right. So, this is the length. Okay. Now, because this is a small element dx, so the force that will be existing between them will also be very small. So let's say this is df, and what we can write, df is equal to g into mass of the rod. So mass of the rod is small m, and mass of the particle is m dash. I'm writing over here m dash, and the distance between them, let's say the distance between this element and this small particle is x, so I'm keeping this x square. All right. Now the problem here is that I put over m, where m is the entire mass of this rod. So I have to replace this m with the mass of this element dx. So overall mass is small m, overall length is small l, L, and the element is dx. This will give us the mass of this small m dx. This is called mass per unit length. So if we are getting mass per unit length of any body and we are multiplying with the small element that we have taken in that body, then it will result to the dm, that is the mass of this small element dm. So we are going to replace this m with dm. All right. Now to dm, so df becomes g multiplied by m by l dx m dash upon x square, right? Now what we have to do, we have to integrate it in order to get the entire force that is existing between the rod and the small particle. So if we are going to integrate this df, we have to integrate the right hand side also, right? Right hand side is this one. I'm writing it properly, lx square. And what we have to do, we have to integrate it over the length. Okay, so our limit will be x is equal to a to x is equal to a plus l. Why? Because the starting point of this rod is at a distance from the rod, and the end point of this rod is at a distance of a plus l. All right. So if we found the gravitational force of this end and we found the gravitational force at this end, definitely we will covering the entire rod, and that is why I took the limit x is equal to a to x is equal to a plus l. Now this df after getting integrated becomes capital F, and whatever the constant will be there, we have to take it out from the integration. So what all the calculation will be g m after integrating, we will be get a l plus a. So this is how we can find the gravitational force that is existing between the rod and the small particle which is having a mass of m dash. So this is the introductions about the gravitation. We will be dealing with this in a more detail in coming lectures. Thank you everyone.